In this video, we're going to learn two new Alteryx tools, and I've put them in my favorites. We're going to learn the RecordID tool and the sort tool. Both of these tools come from the data preparation category. Continuing on from our previous videos, we have this running workflow where I've taught you these various tools, starting with input data tool, and then we looked at a browse tool, a select tool, and we're using this employee data. And the last video we ended with teaching you the filter tool, the formula tool, the sample tool, and the random sample tool. And let's run our workflow. And our data, before doing our sample or random, that was just to show you taking subsamples from our data. Here's our data that we have. If you recall, we've made it nice and pretty. We've changed gender to be uppercase. We've changed the birth date. We've made a change in the job category. Instead of 1, 2, 3, it says manual, office, or hybrid. We've changed the name of education in years. We had a salary difference variable we added, and so forth in previous videos. And here's what the data looks like at this point. All right. Often in Alteryx, it's helpful to have a variable, a column, which gives us the row number for each row. Just simply outputs the row number. In this data set, our first column is the ID number. It's the ID number of the person. But it's not the row number. If we look at the end, for example, this is row 466 of our data set, but the person ID is 473. Because remember, we started with 474 people, and we did some filtering on that data set, and we got down to 466 people in our data set. And so the 466 people are identified by this column. This is their person ID number, but not the row number. This is the row number right here, but as you can see, it's grayed out. We can't write any functions or reference this right here in Alteryx. We need to create a new column in our data that is the row number, and then we can reference that column. And you might wonder, why would we ever want to reference the row number or use it? And I'll show you an example of why we'd want to do that. But this is just for visualization in Alteryx over here. So what we want to do is create a column that looks just like this, but is actually a part of our data set. And that's what the RecordID tool does. So let's go and add a RecordID tool to our data. And as you can see over here, here's the tool configuration for RecordID. We can name the column what we want it. It's by default, it's named RecordID or row ID. And we can tell, all right, this column is going to have a starting value. If we pick 5, that means row 1 will be numbered 5, row 2 will be numbered 6, row 3 and 7, and so forth. So we can just pick 1, that's fine. What type do we want our row ID variable to be? We can, by default, leave it as an integer. If you feel that the size of if your number of rows is pretty big, it's going to be too big to be this data type, then you can make it, you can go bigger. Remember, if you take the number after the int, and you divide it by 8, that's the size that it will accept. So int 16 would be an integer that can be as big as 2 digits. Int 32 is an integer that can be as big as 4 digits. Int 64 is an integer that could be as big as 8 digits. You divide by 8. And if you have an integer bigger than 8 digits, then you just use the string. And you say, well, that's not a numeric data type. That's okay. Remember, we have this function that can convert a string data type to a numeric data type if we want to do operations on it. Remember the toNumber function? toNumber accepts as an input a string, converts it to a numeric data type, and then you can do adding and subtracting, multiplying, stuff like that. So that's okay. If you have an integer that's going to be bigger than 8, place 8 of length 8, then you can use string. But this is fine for this. And then where do we want our new column to be? Do we want it to be the first column or the last column? First column is the default, and that's usually what you should do for visualization purposes. So we hit apply, we hit run, and now we look at our output. And we see here it's added a new column to our data, which is the row number. It looks just like this over here that's grayed out. So record ID is the row number. Column 2 is the person identification number. And you know what? We should probably change that variable name over here in our select tool to, because ID, now that we have this new variable called record ID, then someone might wonder, what's ID? It's the person ID. Once we rename that over here, then the output, even over here and over here, will reflect that. So you see that now it's renamed person ID. All right. Why do we want a variable that has the row number? We might want to do operations on that. So what happens? Suppose we want every fifth row of our data set for some reason. We want to pick out every fifth row. That's the data we want. We don't want any other rows. We're only interested in every fifth row, starting with row 1. So we want row 1, we want row 1 plus 5, row 6, we want row 6 plus 5, row 11, we want row 11 plus 5, row 16, row 21, row 26, row 31, row 36, and so forth. How would we go about doing that? Well, we can use, now that we have this row number variable, we can apply a formula to it. There's various ways to do it, but one way to do it is we can apply a formula. Oh, first off, you might wonder, why don't we just do a sample tool and pick out every fifth row? Well, the sample tool is limited. You can pick the first 5 rows, the last 5 rows. You can skip the first 5 rows. You can take one of every 5 rows. That might do it. If we let n equal 6 and you take one of every 6 rows, that would get every fifth row, essentially. That would get row 1, row 6, I think. Does it take the first, the first 6 rows, does it take the first one or does it take the third one? I think it takes the first one. So that might actually work, sample tool. But what if we want rows 1 and 2, rows 6 and 7, right, like that? Then sample's not going to work. So the sample tool has its limitations. What will always work, though, is doing what I'm about to do. So we create this record ID variable using the record ID tool, and then let's write a formula. If we look at our data, now here's where sometimes you have to do a little programming, a little thinking, a little mathematics per se. If we take the record ID number, subtract 1 from it, and divide by 5, and then ask ourselves, is that an integer? Is the result an integer? For this record ID number, 1 minus 1 is 0, divided by 5 is 0. Is that an integer? Yes. 2 minus 1 is 1, divided by 5 is 0.2. Is that an integer? No. 3 minus 1 is 2, divided by 5 is 0.4, not an integer, and so forth. 5 minus 1 is 4, divided by 5 is 0.8, not an integer. When we get to row 6, though, 6 minus 5 is 1. I'm sorry, 6 minus 1 is 5. 5 divided by 5 is 1. Is that an integer? Yes. 7 minus 1, 6, divided by 5, not an integer. 8 minus 1 is 7, divided by 5, not an integer. When we get over here to row 11, 11 minus 1 is 10, divided by 5. 2, it's another integer. And so it looks like we can write a formula. We can create a new variable, and that variable will be true if record ID minus 1 divided by 5 is an integer, and false otherwise. And then we can filter on that variable, and that will get us row 1, row 6, row 11, and so forth. So hopefully you guys followed that. I have this open. I can write this here. I was just saying it, but we want our formula then is going to be row ID, or record ID is the actual variable name, record ID, but row ID minus 1 and divide by 5. And if this evaluates to an integer, then our new variable, then we want to true, and if not, false. There is a function in Alteryx called isInteger. And it accepts as an input a number, and it spits out as an output true or false if that number is an integer or not. It actually spits out -1 if the number is an integer and 0 if it's not. So let's do that. We have our formula tool. We want to create a new column. We'll call the column keep. And that column will be equal to, we want our record ID minus 1. We want to divide that by 5. And we want to see if this expression is an integer or not. So we're going to use the isInteger function. Again, isInteger, it takes this as its input. And it says, is this an integer or not? If it is an integer, it spits out a -1. If it's not an integer, it spits out a 0. -1 for true, 0 for false. Why -1 for true? I'm not sure why. That's the way it is. Now, do we want this new column to be a string, or do we want it to be a double? It doesn't really matter. We can keep it a string. That's fine. We hit apply. We hit run. We go look at the output from what we did. Here's our new variable called keep. Row 1 answered true, so it spit out true, -1. Rows 2 through 5 answered false, so it spit out 0. Row 6 answered true, so it spit out -1. Row 11 answered true, so it spit out -1. 16, 21. In essence, every 5th row, starting with row 1. And so now we can just write a filter, now we can just use the filter tool, and we can filter and keep all the rows that have a -1 in the keep column. All right, so we can go here to filter. Let's put this up here. And we can filter on, we can do a custom filter, and we can filter on the keep variable. If keep is equals -1. Now keep in mind, keep is a string, so we can't put -1 like that. Since keep is a string, we have to put it in quotes. And so remember the filter, if you remember from before when we did the filter tool video, there's 2 outputs from this filter. There's the true and there's the false. So the true is going to be whatever, if when this is true, that data will go up here, and when this is false, that data will go down here. So the true portion will keep the rows that we want. So you can see here's the true portion. This is where keep equaled -1. You can see keep equals -1 in every row. And what row numbers were we pulling out? Row 1, row 6, row 11, row 16, row 21, just as I said, every 5th row. Which rows do we not keep? Whatever turned out false over here. So rows 2, 3, 4, 5, 7, 8, 9, 10, and so forth. We kept every 5th row starting with row 1. So hopefully you guys can see how the record ID tool enables us to set up a variable which is the row number, and we can actually use the row number and we can do stuff with it. We did it in the formula. You can see row number is now, we actually used it to pull out a specific subset of our data. Essentially, it's like filtering the data, but we do it with the row ID, with a combination of the record ID tool and the formula tool, and then this filter tool. All right, so that's record ID. And then let's look at the sort tool next. Let's apply our sort tool back to our original data here. Here's our data. We now have our row number field. And we want to sort the data. Now there's two ways to sort. One way to sort is just right here in the results output. You can sort on a variable. Let's sort on, we could sort on birth date. So we could click here and hit down. That sorts it in descending order, biggest at the top, or most recent in the case of birth date, to oldest. Or we could sort it in ascending order. So down means descending order, up means ascending order. And that would have the smallest on the bottom or the oldest, and then the biggest on the top. We could do multiple sort in here as well. We could sort by birth date and then further sort it by job category. And what that would do is if two people had the same birth date, it would sort those people by their job category after the birth date. If no one has the same birth date, then it's not going to do anything, right? The second sort won't do anything. Another way to sort is the sort tool. And it's visually a little more appealing. So let's use the sort tool to sort our data and not use this ad hoc approach. So I got rid of that sort. It wouldn't matter if I did or not, but let's get rid of that. Let's use the sort tool. Let's bring it over here to our data. And let's look at our data again. Let's see. What do we want to sort by? What would be a good way to sort? Let's sort our data by job category first. All right. And then after job category, we'll sort it by education level in years. Over here to our sort tool. We'll sort it by job category first. And we'll put it in ascending order. And since job category is a string variable, it's going to do it. Where is our job category? What we should get, what we're looking for then is we have what a job category is, either office, manual, or hybrid. So it would look at the first letter of the string, and it would sort it by the first letter. So the hybrids would be first, and then the manuals would be second, and then the office would be third. Alphabetically, H first, then M, then O in the alphabet. Now, you might wonder, if we go here, what does this use dictionary order mean? What that means is, suppose, let's go to our output again. Suppose that two of these job categories, for some reason they shared, it wasn't the same category, but suppose this word and this word shared the same first two letters. Right? I'm sorry. Suppose they shared the same first letter. So this is an O, and say this was an O. It was a different category. Instead of office, it was called, I don't know, something else with an O, starting with an O. I can't think of something off the top of my head, but suppose it did. Then if you sort job category, and that's the case, you need to sort dictionary order, because then what it will do is it will go to the second letter. If they both have the same second letter, it will go to the third letter, and then whichever one has the earliest third letter in the alphabet, that would become first if we're doing ascending order, and then the other one would come second. So hopefully that makes sense, the dictionary order. It goes letter by letter. For most situations, you don't have to use dictionary order, but you should probably get in the habit of always just checking the dictionary order box, because it can't hurt anything. It can only help. All right. Well, we're going to sort by job category in ascending order, so it should be hybrid, manual, and then office. And then after that, let's sort by, let's see, education. And then we'll sort that descending order, highest level of education first. And then we'll sort that, after that, we'll sort it by gender. We'll do that in ascending order. So females would be first, then males. That as long as their education was the same, we would sort it. And then salary, we would sort last by salary. Let's say we want to sort it by our salary in descending order, highest to lowest. And so it's important whatever one you put first, that's what it sorts the data set first by. And it sorts the data set in order of what you put here, in order of the variables you put. So we said job category, ascending, education in years, descending, gender, ascending, and salary, descending. And let's sort. Let's look at the output. All right. It's sorted by job category first, and it did it in ascending order. So all the hybrid jobs are first. Then you'll see the manual jobs, and then the office jobs at the bottom. Then we sorted it by education in years, which means if two people have the same job category, it'll sort those people in order of their education, and we're doing it descending. So we can look here, how many people have the same job category? How many hybrids are there? Looks like there's 27. And so it sorts those 27 people. After sorting, we sorted the whole data by job category. Hybrids are first, and then it further sorts them by education. So the person with the hybrid job has the most education is 15 years, and then 12 years. A few people had 12 years, and then some people had 8 years, and so forth. After sorting by education, we sort by gender, which means if two people have the same job category and the same level of education, then it further sorts those people by gender. And we're doing it in ascending order, females and then males. There are no females, though, in the hybrid job category. Otherwise, there are no females in the hybrid job category who have the same level of education as a male or as another female. In fact, there's no females at all in the job hybrid job category, and so you don't see any females here. However, in the manual job category, it sorts first by job category, so hybrid first, then manual, and then after that it sorts by education. There was a person with 19 years of education. They happen to be a male, so that they appear first here because they have more education. Then there's two males with a manual job category and 18 years of education. And then if we come down here to a job category manual and 17 years of education, there does happen to be a female there, and so they put the female first because we sort after sorting by education. Job category first sort, education second sort, gender third sort, and you can see that. And then over here there are many folks who have a job category of manual, education in years of 16, so that's high school plus 4 years of college. And it sorts those people, females first, then males. You can see all the females were sorted. Where does it start? Right here. And then there's a bunch of males that also have manual job category and 16 years of education. It puts them second because we're sorting gender in ascending order. And then finally, we sort by salary, descending order. So let's look at the manual job category, 16 years of education, females. It sorts those individuals then by salary. So if we ask the question, who is the highest paid female who has a manual job and has 16 years of education? It'd be this person with person ID number 72. They have the highest salary because we're sorting by salary. I'm sorry. That's beginning salary. We're sorting by salary. It'd be this person with 54,000. The same person, 72. If I asked, who's the highest paid male who has a manual job and has 16 years of education? It would be this individual right here. And there's their salary, $52,650. $52,650 a year. So hopefully that makes sense to you in the order at which it sorts. The order you put these here in is important. All right, that concludes this video.